Let's review the properties of parallelograms. So parallelograms are quadrilaterals, which means they have four sides. And some of the properties of parallelograms include that opposite sides are parallel, the opposite sides are congruent, opposite angles are congruent, the angles that are next to each other equal 180, and the diagonals bisect each other. So what we're going to do is we're going to solve a few problems using these properties to help us set up and get the final answer. In this example, we are going to solve for parallelogram WXYZ. So here the instructions say WXYZ is a parallelogram. Find the side and the angle measures. So we're going to start with the side measures. So we're going to find from W to X and from Z to Y. And what we know is that since opposite sides are congruent, once I found one side, I also found the other, which means we can use that to set up our equation. If these sides are equal, that means I can set them equal to each other. 6a plus 10 is equal to 8a minus 4. And by setting this up now, I can actually solve for a and plug it back in. So let's get all the a's on one side. So I'm going to subtract 8a from both sides. And I'm going to get negative 2a plus 10 is equal to negative 4. The next thing I want to do is subtract 10 because again I want to get a by itself. So I'm going to change colors. So this time I'm going to subtract 10, subtract 10. I'm left with negative 2a is equal to negative 14. And the last step to get a by itself would be to divide by negative 2. So I'm going to divide both sides by negative 2. And that gives me a is equal to 7. But of course I have to actually answer the question. I want to know the side and the angle measures. So if I want to know the side measure, I'm going to plug a in. So I have 8 times my 7 minus 4. So I have 56 minus 4, which is equal to 52. So I know the lengths of my sides, WX and ZY, they are both equal to 52. Divide by 27 on both sides. And there I'm going to get B is equal to 7. So now I actually want to answer the questions. What are these angle measures? And they are not equal to each other, so I am going to find them both. So I'm going to take the first one, 18B minus 11. I'm going to go ahead and plug in B is 7. So I have 18 times 7, which is 126, minus 11, which is going to give me a final answer of 115. So 115 degrees. That's this one, 115 degrees. And I know that they should be 180 together. So when I plug this 7 in here, I can be pretty sure that my answer should be 65 because that's the only thing that's going to give me 180. But let's plug it in and check anyway. So I have 9B. 9 times B, B is 7. 9 times 7 is 63 plus 2, which is 65 degrees. So this one here is 65 degrees. So again, what we did was we used the properties of parallelograms to solve. We knew that the opposite sides were congruent, so we were able to set that equation up. And then we also knew that consecutive angles equal 180, so we were able to set that equation up. In this problem, we're going to use properties of parallelograms to solve for JG. And JG is this piece of the diagonal right here. And what we know about diagonals in a parallelogram is that the diagonals bisect each other, which means they cut each other exactly in half. So just in case you wasn't sure, right here, EFGH is this indication, this image stands for the word parallelogram. So it's telling you that EFGH is a parallelogram. So since it's telling you it's a parallelogram, I should know that the diagonals bisect each other. Since I want to find GJ, I'm going to concentrate on this diagonal here. I know that this piece should be equal to this piece, so that means that I should be able to say that 3W is equal to W plus 8. And in order to get W by itself, I am going to subtract this W from one side and put it on the other. That leaves me with 2W equals 8. The last step to get W by itself is to divide. So I get W is equal to 4. Now I have to actually answer the question. It wants to know what is JG. Since JG is represented by the expression W plus 8, all I'm going to do is plug that in. So I get a final answer of 12. Additional shapes that we're going to work with are called kites. And so now we're going to talk about the properties of kites. Now kites are quadrilaterals, which means they have 4 sides, but they also have something special. 2 pairs of congruent consecutive sides. So you can see here I have a kite. So it has 2 pairs of congruent, equal, consecutive, next to sides. So as you can see, these 2 sides here are next to each other and they're congruent. And these 2 sides are also consecutive next to each other and they are also congruent. So that's what makes it a kite. Now a kite also has some other properties that you're going to want to know. We also know that in a kite, the diagonals are perpendicular, which means they create 90-degree angles. So right here, these diagonals create perpendicular intersections. So I would know that all of these angles in here are 90 degrees. That may help me when I'm trying to solve problems because I know a lot about triangles. One of the other properties is that there is 1 pair of opposite congruent angles. And so I'm going to show that by doing this. So for instance, if this whole shape is my kite, this angle is opposite of this angle, and those angles may be congruent because there is 1 pair of opposite congruent angles in a kite. So these are some of the properties that again will allow us to solve, relate back to triangles if needed, set up equations in order to solve for variables, and let's not forget to actually go back, plug in our answer, and find the final answer. In this problem, we're going to use properties of a kite to answer the question. Now, I kind of hinted to this in the other video. Even though we are in the parallelogram section and we're dealing with a rhombus, a kite, trapezoid, and so on, what you're going to find is that everything we needed to know about triangles is going to keep coming back up over and over again. Whether it's what do you know about a right triangle, or what do you know about an isosceles triangle, and so on. It's going to constantly keep bringing itself back up again. So what I want to do here is, and this is what we always try to get you to do in class, is whenever we get a new problem and we're reading the directions, we want to mark the shape appropriately. We want to mark it with what we know, and we also want to make sure we know what we're looking for. So in this case, it's telling me in kite ABCD, which I already have written here, the measure of angle D, A, and B. So D, A, and B, that's this entire corner here. It's saying that it is 54 degrees. And it says that the measure of angle CDF. So C, D, and F. So that is just this piece of an angle right here. And that is telling me that it is 52 degrees. And it wants me to find, I'm going to change the color. So the red is what I know. And I'm going to use purple to indicate what I'm looking for. I'm looking for the measure of BCD. So B, C, and D. So I'm actually looking for this entire angle. Now, I know a couple things about a kite. And one of them is that on a kite, the consecutive sides are congruent. So that means, and I am going to use a different color, I know for a fact that this side is equal to this side because those are consecutive congruent sides. And I also know that this side is congruent to this side. Now, the reason I wanted to make sure I include that is because that may give me a hint as to something else that I know that can help me solve this. So, I know if I completely ignore this, because honestly, in order to find this, this is like extra information. I don't really need to know anything about that. But if I cover this up, what I see here is a triangle. And it's not just any triangle, it's a very special kind of triangle. It's a triangle that has two sides that are equal. We call those an isosceles triangle. And what I know, and I'm just going to redraw this so that you can see it. What I know about an isosceles triangle is that when these sides are equal, so are their base angles. So I can see here my base angle is 52. Well, that would mean that this base angle is also 52. So I know this is 52 and this is 52. And the last thing I want to do is find that missing angle. Well, what do I know about a triangle? All three sides, or all three angles, are equal to 180. So I can literally take 52 plus 52 plus the angle that I'm missing, angle C, and I'm going to set it equal to 180. So here I have 52 and 52, that's 104. Last step to get that missing angle all by itself, I'm going to subtract by 104. So C is going to be equal to 76. So the missing angle that they're looking for is 76 degrees. So as you can see, even though the shape started off as a kite, one of the things that I know about a kite is that these two sides are equal. And immediately, an isosceles triangle is created. And not only are these two smaller, is this one big isosceles triangle, but I also have smaller triangles in here that have 90-degree angles. So there's always a lot of different ways that you can look at the problems before you actually solve it.